3.4 exponential and log functions. So I'm going to split this into 2 days. Today, you're going to be primarily doing exponentials. And then tomorrow, or next lesson, you'll be working with the log functions. So, to review. So when you have bases that are the same, so E is a base. When your bases are the same, your exponents are the same. So E is the same base. So then I can say negative x squared is equal to negative 3x minus 4. And then solve for x. It's a quadratic. That means a power of 2. So I can say 0 is equal to x squared minus 3x minus 4. I just added x squared to both sides. That's all I did. And then this is a simple ACB problem, where this is x minus 4, x plus 1. So then x is equal to positive 4, x is equal to negative 1. So again, review, we kind of did this already, but that's how you work with a same base, different exponent. So to go from there, so here we're solving exponential equations. So the x is an exponent. Okay. So we got to work our way in. So imagine that the parentheses is kind of like a barrier. You can't get there. So let's divide by 3. Let's get rid of that 3 first. 2x is equal to 14. So now the next step. So we've seen this before, where if we can turn this into a power of 2, or 2 to some power, let's say 3. I know it's not 3. But if we can have the same base, then the power can be the same. But you cannot turn 14 into a base 2. So this is where log comes in. I want to find a way to bring the exponent down to make it the same plane, the same level that we're used to. Right now it's in the exponential world. We want it into the regular number. So how you can do this is if you take this base, if I do a log of that base to both sides, what's going to happen is if the base is the same as that number, they will reduce to 1, and you will have your x left. So what really happened with this x is, remember the rules of exponents, it actually comes to the front, and then this reduces to 1. So you have x is equal to log base 2 of 14. And that's simply just put that in a calculator. So if you're using the Desmos calculator, you don't have base 14 or base 2 of log. You have a regular log base 10. If you're using a different calculator, which they no longer have on the self-service, this one you can actually do log, and then you can do base 2 of 14. That gives you the answer of 3.807. So this is the reason why we don't do a lot of changing in the base, because calculators can do it now. But if you're using the Desmos calculator and you don't have a change in base, remember from last time we said this is the same as log base 10 of 14 and log 2. And you can put that in your Desmos calculator. So function log of 14 and log of 2. And you see I got the same answer. So 3.807. Okay, so that's how you do it. For B, so this is for B, e to the x plus 5 is equal to 60. So this 5 is not with the x. This 5 is down here in the non-exponential plane. So let's get rid of that 5 first. So I have e of x is equal to 55. So similar to here where I did a log base 2, I can do a log base e. So I can do a log base e. But remember that a log base e, we call it the natural log. So you can do ln, or natural log, to both sides. And this will reduce to 1, so you have x equals the natural log of 55. Put that in a calculator. So I can do ln of 55, and I have 4.007. So these two are just practice. They're done same as those. Move on to the next part. It just gets a little bit challenging. Challenginger. But the same thing. Work your way inside. Okay? My ultimate goal is to get to this t. But I have a lot of things blocking me to get there. So let's get rid of that 4 first. That's plus 4 both sides. I have 2. 3 to the 2t minus 5 is equal to 12. Now I can divide by 2. So I have 3 2t minus 5 is equal to 6. You cannot divide by 3. Right? You cannot do that because this is attached to the 3. So this is where I need to bring that exponent down. So I can do that by doing a log base 3 to both sides. And then that will reduce. So you have 2t minus 5 is equal to log base 3 of 6. So this is the part where you really should use parentheses around the 6. Because the next part where we add 5, I guarantee you somebody, or even you're going to try to add the 6 and the 5 to make it 11. Which is not true, because this is a number. The 6 is attached with that log. So this is just log base 3 of 6 plus 5. Right, the 5, it's its own. And then lastly, we can just divide by 2. It's just not going to be a pretty number, but that's fine. Just put that in a calculator. You can get this on your iPhone, or you can find another scientific calculator that will work just fine. I don't know what I did. So I can just go, I don't know what that is. Fraction. And then log base 3, 6 plus 5, and then divide by 2. I get 3.315. Okay, and then this one is done very, very similar to that too. So for the homework, on number 15 and 17, so number 15 and 17, you won't know how to do that yet until Friday. But the rest of these, you should be able to do it just fine. So you can save those two, and I'll go over how to solve them on Friday.